Okay, so basically these two graphs are just, or functions are just graphs, things that we can draw. Okay, remember you've got x and you've got y. X is the independent variable, y is the dependent. Okay, so if I substitute an x into an expression, I can solve for a y. Okay, that's the key, that's the relationship. Okay, so when looking at the exponential graphs will have something like y equals 2x. Okay, so you can put an example there, e.g.
For the
exponential first, yeah, because exponential is the starting point. The log is actually derived from that. Okay, so e.g. y equals 2 to the power x.
Y equals 2 to the power
X, yeah. Okay, y equals 2 to the power x. Okay, so how would you draw that graph?
It's a parabola.
It's not a parabola, it's an exponential graph.
Yeah.
A parabola is ax squared plus bx plus c. A straight line is y equals mx plus c. Okay, so that is a very specific graph. Okay, so how do you draw any graph?
Get points.
Exactly, find points. Okay, so let's sketch a table. Let's put one column for x and a column for y. Okay, we won't put too many points. Let's put 6 points. Okay, so the only way you're going to be able to sketch the graph is by getting points and by looking at its shape. Okay, so exponential graphs will have a specific shape, and that's what we're looking at. Okay, right. So if we have y equals 2 to the power x. Do you agree that x is the exponent? So the bigger the exponent, what happens to the number?
Increases.
Exactly, the bigger the number. Okay, because exponential graphs would be like, so 2 to the power 1 is what?
1.
No, 2 to the power 1.
2.
Yes, okay, because it's times by itself, basically. Well, no timesing by itself. Okay, so that's what we're looking at. So we're looking at numbers that can be put on a Cartesian plane that we can use to get the points on that graph. Okay, so x, let's take negatives as well. Let's put negative 2.
For x.
Yeah, so minus 2 as the first point. Well, yeah, first value of the first point. Okay, so if I know x is minus 2, how am I going to find y? No, you know x is minus 2. How do I get y?
Substitute.
Exactly. Okay, so grab the calculator and put in 2 to the power minus 2. Two to the power minus 2 is a quarter, 1 over 4, or 0.25. Okay, let's put in minus 1. Okay.
Okay.
Let's put 0. Okay, that one's a key point, hey? Because do you agree, anything to the power 0 is what?
Yeah, 1.
Always 1. Right, let's use slightly bigger numbers. So let's use 2, then 3, and then 4. We'll skip 1 just so we can see how big the numbers get.
2,
3, and 4. Let's do one more. Yeah, 4 to the power should be 16. Okay, so what do you notice? The graph starts out very small and gets bigger and bigger and bigger. Okay, what happens if the number is very small? What happens if x is minus 100? What do you get? A very, 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 very small number. Okay, you've got to a negative exponent even, so that means it's tiny. Okay, it's literally 0,0 all the way to a number. Okay, right, so what do you have? You've got a graph that is very small on the one side, it gets bigger and bigger and bigger and bigger and bigger as the numbers get bigger. Okay, so draw a Cartesian plane, x and y axis. Let's draw it, and then we can look at notes relating to the graph.
Should the x-axis be in the middle?
Yeah. Well, a little bit further down, because you're not going to need anything in the negatives. Okay, y, because if you look at it, y equals 2 to the power x. Okay, if I put in any number, will I get a negative? A negative answer. If I put in any value of x, so we put in negative x's, what do we get as y's?
Positives.
Okay, so if I put in negative 100, was the answer positive or negative?
Positive.
Still positive, it wasn't negative. So is it possible to get negatives? No. Okay, so let's plot the points. Minus 2 and a quarter. Okay, minus 1 and a half. Okay, 0 and 1.
Okay.
2 and 4. Keep going, plot the rest.
I'm not going to plot 4 and 16 because it's too...
Exactly, because it's exponential. So, join the dots. No, not with the ruler, with the freehand curve.
Yeah.
Because it's curving, it's exponential. Okay, and then you draw arrows at the ends because the graphs can continue forever and ever and ever. Right, so if you look at the left, the number gets the numbers get smaller and smaller and smaller, but will it ever touch the x-axis?
No.
Never. Why? Because I cannot put in a number into an exponent to get 0. It's impossible. Okay, if I put in a very big negative number, I get a very small number answer.
Yeah.
If I put in 0, I get 1. If I put in a very big number, I get a massive number. Does it make sense? Okay, so what is that graph representing? An exponential function.
Yeah.
Okay, properties of an exponential function you can write down. X is the exponent. Okay, so we're substituting in the exponent. Okay, so if x is the exponent, comma, the y can never be 0. Okay, so it doesn't matter what x you put in. You can put in any x you like. you will never ever get 0. Okay, so that line will keep getting smaller and smaller and smaller, but it will never touch the x-axis. Okay, so exponential graphs only have a y-intercept. And that's what an exponential function looks like. Okay, we need to show another graph. So on this side, just write down y equals 2 to the minus x. Y equals, we're going to draw another graph. We're going to draw the same graph, same axis. It's just, you're going to see it's the mirror image. Y equals 2 to the power minus x. Right, so let's plug in points again. Let's plug in the exact same points. So if x is minus 2, what do you get as an answer?
If you put in minus 2, then 2 to the minus 2. Minus 2 will be 4. Minus 1, 3, 2.
Okay, so let's draw that. Do they share a common point?
Yeah.
Which point?
0 and 1.
Exactly. Okay, 0 and 1 will always be something that you would have 0 and something. Okay, because the exponential graph only has a y-intercept. It'll cross the y-axis at some point in time, but it'll never ever touch the x-axis. Purely because of the maths. Okay, if you have a variable as the exponent, you can't substitute something in to get 0. No, draw it on the same axis. It's a mirror image. It's like this, see? It's like that. The one does that, the one does that. Okay, it's just use 2 different colors. You can draw another graph if you want to, but I don't think it's necessary. It's the same graph, the only thing different was what? Minus x or plus x. So it's a mirror image. Okay, so plot those points and then join the dots. Now 1/8 is lower than 1/4. Okay, it's smaller even. So it'll get closer and closer and closer to the x-axis, but it'll never touch the axis. it'll continue forever. Okay, enjoy the dots. You need to label these graphs as well, because you won't know which one's which. Okay, so write down the equation next to each of the graphs. Okay, so the one was y equals 2 to the minus x, which is the one that you just drew. And the other one would have been y to the 2x.
Okay, so this one, the blue one is y.
The one that you just drew.
2 to the minus x. This one is x.
And let's see what the text work program gives you. Yeah, we'll come back to the logs. The logs is a bit more tricky. Yeah, here. Okay, that's solving for logs. No. Okay, that's also solving for logs. Okay, so we've actually covered what an exponential graph is. The textbook will probably have more than what they have here in the work program. Okay, let's draw a log graph. Okay, so that covers the exponential graph. Okay, so you've looked at an exponential function, you've drawn it. Let's look at a logarithmic function, and let's draw it. Okay, so subheading here you can say logarithmic function. Let's start by understanding what it looks like. Let's draw it. Okay, underneath this, you're going to write big NB, and then this is what you remember with the log function. Okay, so 2 to the power 3 equals what? 8. Okay, what did we say earlier? A logarithmic function is an expression of the exponents. Do you agree? Okay, so what are we going to do? What is the exponent?
3.
Yes, okay, so that's the base, that's the exponent, and that's the answer. Okay, so how can I represent the exponent as the subject of the formula? Well, it'll be this. 3 equals log 2 of 8. Okay, so that's the exponent equals the log of the base of the answer. Okay, do you know how to use the log button on your calculator?
No.
Okay, so can you see it? Where is the log?
2.
There's the log. Okay, there's 2. Why do you have that one? It's because you can put in a base and you can put in an answer. Okay, so let's use that one. Put in 2 and 8.
3.
Yes. Okay, so that's what you write down. That's what you need. That's everything when it comes to a log. Okay, base, exponent, answer, and then just manipulate and change the way it looks to solve for whatever you want to solve for. Right, and that's, I even still use that now, okay, with other courses when dealing with logs. Right, it's the basic. It's a basic principle. It's like the accounting stuff. It doesn't matter how far you go with accounting. An asset's an asset. Okay, a log is a log. Okay, a log has a base, an exponent, and an answer. Okay, the log gives you the exponent for the base and the answer. Okay, so as long as you've got that, then you've got everything. That's the most important thing. That's the most important thing to remember with the log. You just write it down. 2 to the power 3 equals 8. Log base 2, 8 equals 3, and then you've got what you need to do the log questions. Okay, obviously there are rules and that, and we'll look at that. I see the textbook is, well, the work program gets quite a bit of that. We'll have to check the second textbook for the rest, because this first textbook doesn't have logs anywhere. It has trig, it has the sequence and series of differentiation, but we've covered all of that stuff. Yeah, so I do think we need the next textbook. Yeah, but we'll check that on Friday. Okay, so you've got what you need in order to deal with the log. Okay, so let's draw this thing. Okay, so you can say e.g. and then you can say sketching a log graph. Okay, so earlier we drew the graph y equals 2x. Let's write that down again. Y equals 2x.
Okay, what am I doing?
Okay, y equals 2x. 2 to the power x, yeah. Okay, bracket, you can just say C before, C previous page. Okay, so I'm just referencing that graph as a reference.
Yeah, that's fine.
Okay, then the log graph is going to be y equals log 2, log base 2. So y equals log base 2, so small little 2, with a big X. Okay, there. Alright, so y equals log base 2 of x. Okay, so how do we find points on a graph? Those two graphs are unrelated, but they link in some way, but you'll see just now what it looks like. Okay, how do we draw a graph?
Points.
Find points, exactly. So let's find points again. But points for the y equals log base 2x. Those are the points we want, okay, because you need to draw that graph.
Okay.
Okay, so let's use,
the same points as
yeah, let's use the same points.
Minus 2.
Okay.
Okay.
Label it x and y. Right, so how do I find y? Substitute x. Okay, so on your calculator, use the function y equals, well, yeah, log base 2 minus 2. Don't forget to put brackets, so let's just see how it looks like. Log 2 bracket minus 2 equals, okay, an error. So what does that mean? Minus 2x isn't a possible answer. Okay, so you no solution basically. Okay, next. Put in the -1, what do you get?
Also.
Good. Okay, so what can we write down there?
Also.
What can we write down there?
I'm just saying E for error.
Yeah, but no, for 0, yeah, well, for 0 you wouldn't have anything, correct? Okay, 2. Okay, now we've got answers.
6 can I round it up? Okay.
How are you putting it in though? Let's see. Are you using a bracket? log of 4. Yeah, that's fine. Okay, we're going to need a few more points then. Let's just extend it a bit further down. Let's use 6, 8. That's enough. Okay, 2 more points. Okay, let's draw the graph.
Okay, so
This one you're going to need it in the middle. Okay, you need more space. Okay, so plot points. 2 and 1. X is 2, y is 1. 3 and 1, 6. Okay, that last one. Just check that last one when you put an 8 in.
when you put an 8 in,
Hmm.
okay, just write it on this. What is 2, 3, 4, 6 is 25. And 8 log to 8.
Is it 3?
Yes.
Okay, that's fine. Okay, the numbers are getting bigger, so that's good, that's fine. Okay.
So is it a curve or?
Is it possible to get numbers between the error? So where did you get the error?
1 minus 2 minus 1 is 0.
Okay, at 0. Okay, 0 was the last number that had an error before I got an answer. Could I put 1 in?
Yeah.
Let's put 1 in. What do you get?
Yeah.
Okay, so let's put that in. No.
1.
X is 0. No, X is minus 1.
No, it's 1. So minus 1. We can get minus 1.
Well, positive 1, yeah, so 1.
So
If X is 1, what was y? What was,
1, so
yeah,
it's
there we go. Okay. Right, can we get numbers smaller than 0? Well, smaller than 1, but between 0. A fraction, do you agree? Can we put a fraction in? Yes, we can. Okay, so if you put a half in, what do you get?
minus 1.
Good. Okay, so let's put that in. A half and minus 1. No, a half. X is a half. Y is minus 1. X is a half. We substituted in a half. Where is X a half? That's X minus a half.
Oh, so yeah.
That's X a half. Minus 1.
Okay.
Okay, let's just put one more point. Let's put in.
What is that? X is a half. 3.5 and goes on here. Minus 1. Okay.
Okay, let's put in minus 0, 0,1. 0,1 is 1 over 10.
minus 3.
Okay. So where would a tenth be? A tenth is small.
X is
A tenth. 1 over 0.1.
So yeah, 0.1 and y is minus 3.
There we go. Okay, let's join the dots. Okay, so this graph is curving that way. Will it ever touch the y-axis? Never. It will never touch the y-axis, but it will get so close, but never ever reach that point. Right, so you can see they've actually done both graphs on the same axis, which is actually good. See, there's the one that you drew previously, there's the other one, there's the log graph. Okay, it's a mirror image, see? It's like a butterfly. Okay. Alright, so that's a logarithmic graph. Now we need to write down rules. Okay, so new page, new like section, log rules. Okay, so rule number 1, you can label these as they're okay, so the first one, log A as the base, so A is the small letter, log small a, X is the big letter, that's the answer, to the power n, X to the power n, okay, can equal, n is outside the log, so n, then multiply log small a to the x, small a, and then to the big X. Okay, that's the first rule. So what does that rule say? That rule says if I have an answer with an exponent, I can take it out and I can put that number in front of the log. Right, so example underneath that, e.g., let's write down log 2 of 4 to the power 3. Log base 2 to the then 4 to the 3. Okay, is the same as equals 3 log 2 4. Okay, there's the first rule. Okay, second rule. Log small a then to the xy. Okay, like this. Okay, log a to the xy. Okay, xy. Xy is the answer. X times y. Okay, like that. X times y. Okay, so if you have a log where you have an answer where x is multiplied by y, what can you do? You can split it. And you can split it into that. You can split it into a log ax plus a log ay. That's the rule. Okay, these are things you just study and learn. It's like exponents. When you, with exponents, let's think back. Okay, a to the 2 times a to the 3. What do I do to the exponents? I add them. Okay, so that's a rule. Okay, let's do a question, e.g. underneath this. Okay, log, let's use 2 as the base. Log base 2. Let's use 12. Let's write down 12. Okay, so what factors do we have for 12? Give me any factors of 12.
1 and 12, 2 and 6.
Okay, let's use 2 and 6. That's better instead of 1, because 1 doesn't really help us. Okay, so then that could be equal to log base 2 of bracket 2 times 6. Okay, equals log base 2 plus log base 2 6. Does it make sense? Okay, you're splitting it. Right, so do you see how you use these things? Okay, it's manipulating the question to get you something that you might be able to use elsewhere to simplify. Okay. Right, because log 2 is what? Check that. Log 2 is a nice simple one. Log 2 I think is 1. Yeah. Okay, so then that can be simplified. Okay, so that's the first one. Let's check. Log a to the 1 equals 0 always. Log a1 equals 0. Okay, that's another rule. Beneath that, log a, so the same number, log a.
So is this a different rule now?
Yeah, different rule. Log a. Okay, so if I have the same thing, then I'm logging it. So log 10, log 2. See, earlier I had log 2. I knew it was 1. Okay, why? Because of that rule equals 1. Right, and the last rule is this. Log a is the base. Okay, then you have a fraction.
Log a,
Yeah, then you have a fraction. The answer is a fraction. It's x divided by y. So x over y. X over y. No equals. No equals. A logarithmic function needs an answer. Right? It's log base of an answer
x
over y.
Yeah.
X over y
Equals
equals the log ax minus the log ay.
yeah.
Log the base a. Yeah, a log always has to have a base.
Yeah, no, that is
Okay. If it doesn't have a base, what is that's actually a good thing to think about. So if I have log, let's just say log 2, what is the base? If they don't specify, the base is 10. Okay, so let's write that note down. Okay, so on your calculator, when you just write down the log on its own, the base is actually 10.
Okay, so
Okay.
if there's no base, the base is 10.
Yeah. Okay, so let's write down an example. Uh, 10 squared is 100. So 2 equals log 10 of 100. Okay, so on your calculator, let's write down this example. E.g., 10 squared equals 100. Okay, so if we apply the log rule, we know that 2 equals log 10 of 100. I'm just applying that. So I wrote down this, and I applied that. Okay, because what does this say? Exponent equals log of the base of the answer. Okay, so what will I have? 2 equals log 10, 10. So do we write down base 10? No, you don't. So on your calculator, don't use the one where you can put in base 10. Just use the normal log. Use that one. Okay, just write in 100. Does it give you 2? Yes. Okay, so see. So that's the point I'm trying to make, is that if there's no base, so if you see a question just with log 10, log 5, log 20, that means the base is 10. Okay. Is that okay? Right. Let's solve. Okay, so we've got an example here. So these are just Examples where you've got to find x or y. Okay, so first example, 81 equals 3y.
So is this solving, right?
Yeah, solving. There's quite a bit of this actually. It's applying the rules and solving for something. You just say solving for an unknown. So the unknown could be the exponent, or the unknown could be the base, or the unknown could be the answer. Doesn't matter, it could be anything. But you're going to use this. Okay, that. You're going to move it around, change it around, and you're going to apply the rules. Okay, so if you want steps here, let's do that. Step number 1. Write down the logs. I don't know what you want to call this format. I just want to call it the normal format. So this is like normal format. Okay, a log with a base with an answer. That's like the normal format. Okay, so when I say write down the logs,
Write down normal format.
well, yeah, you can say that. Write down the normal format of the logs. Okay, that requires the rules. So you would have to say there as a sub, like heading to that point, use log rules if necessary. Okay, so what we're trying to do, we're trying to simplify those logs to something that looks like this, because I can work with something that looks like this. I can't work with something that looks like this, with a fraction and a division and all that stuff. Okay. So basically just apply the rules to get a simple log. Okay, then number 2 would be rearrange to solve for the unknown. Okay, like this one. So we'll describe it when we do some examples. Okay. So rearrange to solve for the unknown. Okay, so let's apply what we know. Let's look at the first example. Right, so example, find log 81. That's what they say. Find log 381.
Base 381.
Find log base 3 and then answer 81.
Okay.
Okay, so they want you to find log 381. So in other words, what does that equal to? Okay, you know you can do that on the calculator. Okay, and you know the answer is going to be what? 4. You can type it in. Okay, but you shouldn't do it that way if it's a question that says solve, because they're going to want to see your steps, your algebra. Okay, so how can I write this? Well, make that equal to y. Or x or anything. It can be anything, doesn't matter. Okay, so do you agree you're solving for it, right? Okay, so how can I find the log of that number? Well, I need to rearrange it. Okay, so how am I going to rearrange this? Write it down in this format, the exponent. Okay, so what is the exponent here? Yes, the 3. The 3 is
the base.
The y actually. Yeah, the base is the 3. The y is the exponent. Okay, so 3 is the base. Write down 3. The exponent is the y. Write down the y.
Where must I write down?
Exponent. The exponent.
As an exponent.
Yeah. Equals. What does 81 represent? The answer. Which is? Exactly. Okay, so do you know what the prime factors of 81 are? What prime number goes into 81? No, well, 1 isn't a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number.
81 divided by 3.
That'll work. Okay, so you can put in 3. So 3 is the prime number. So do you still remember this thing? 81, 3. That goes 27, 9, 3, 1. No, 3, 1. Okay, so there's it. Okay, so the prime factors. So 81 can be written as this: 3 to the power 4. Okay, so I'm dividing 81 by 3 times. 4 times 3. Okay. Right, so let's write that down. 3y. You can if you want to. That's just the prime factors. 3y equals 3 to the power 4. Okay, so what do you have? Do you have the same base? So what must y equal? Y must equal 4. Okay, it's a mirror image, right? What's on the left must be the same as what's on the right. Don't cross out the 3's because you don't cancel the bases.
Will they fall away when working with the y?
Well,
I know
they don't fall away. They're there. It's just they have the same base, so the top must be the same. Okay, so that's important. Finding prime factors to get a number. Okay, that's the first example. Right, so that was the one that you see, you solved it. Okay, they've done all of that. Okay, here's the next one. Number 2. Solve log base A 40
base A
40 minus 3 log AX.
AX is the base.
Yeah, A base. A is the base, X is the equals log A5. Okay, that's the equation. Solve the equation. Right, so what are we going to do? Well, what do we have? We've got logs and we've got different bases. Well, no. Do we have all the same bases? Yes,
Yeah.
we do. Okay, can we apply a rule here? Yes. Okay, what do you have there? The 3 log AX. Can I convert that? Yes. Okay, where's the 3 going to go? As the exponent for the x. Okay, so next line. Log A40. Log A40 minus log A x to the 3 equals log A5. Okay, so now what you're going to do? Can you apply another rule? What other rule can you apply there? What else do I have? I've got a minus separating 2 logs. Do I have a rule with a minus separating 2 logs?
Yeah.
Yes. So what can I do? Apply the rule. Okay, so what does the rule say with the negative? The negative was the splitting when I had the divide, exactly. Okay, so now are you going from this side to that side? Yes. Okay, so let's write it down. Log base A bracket, what is the numerator going to be? Look at the rule.
40.
40, yes. Over
Yeah.
okay, so yeah, you've got the numerator, just see the denominator. 40 over
3.
x to the 3. Close brackets. Equals log A5. Okay, so do I have the same log on both sides? I've got log base A on the left, I've got log base A on the right. Those two numbers, the bracket is going to equal the 5, do you agree? Okay, it's a mirror. It's like what you had over here. 3y equals 3 to the power 4. So the y must be equal to the 4, right? Okay, so if you've got log with the same base, the things have to be the same, right? Okay, so highlight that. The brackets must be the same. Okay, the two brackets have to be equal. Okay, so next line. Therefore, 40 over x cubed.
Therefore, 40 over
X to the 3
cubed, yeah.
equals 5. Solve for x. That you should be able to do now. That's normal algebra. Okay, so the log stuff was just the log stuff that we had to use in terms of rules. Okay, now you've got normal algebra. Okay, so 40 over x to the 3 equals 5. What is x equal to? Solve for x. Let's check your algebra.
So it would just be 40 equals 5 times 3x. X cubed, I mean.
Solve for x.
So we're going to move it there. So it would be 40 equals 5 times x cubed.
Okay, that's fine. If you want to move that side, that's fine. You can do it however you want, as long as you get the right x. Just apply the normal mathematics to the algebra.
Am I doing it right? Is that right?
No, that's fine if you want to take that to the right.
So then we can say 40 divided by 5 equals x to the 3.
Okay, that's fine. That still follows the correct rules. Okay, so what is 40 divided by 5?
Then it's 6.
Yes, okay. Good. Okay, now what do? Prime factors. Prime factors of 8. A prime number that can go into 8. Like what I did earlier, move that page. Yeah, similar to this. See, we did the same thing for 81. Okay, prime factors of 81 was 3. 3, 3, 3, 3, 4 times. What's the prime factor of 8? A prime number that can go into 8.
2.
Yes. Okay, so 2 to the power what gives you 8?
3.
Exactly. Okay, so write that down. 8 can be written as 2 to the power 3 equals x to the power 3. Okay, do you know what an x is? Yes. It's a mirror. If you have 2 to the power 3 on the left, and that's equal to x to the 3 on the right, if the exponents are the same, the base has to be the same. Okay, and that's it. Alright, so that's another bit. That's another example. Okay, here's another example. These are quite good because they practice the rules. Right, example 3. Okay, this one I think maybe you rather write it down because it's a bit too long to explain. Okay, there's brackets and all of that. Okay, so just write that question down and then we'll look at it.
This one, yeah.
No, the top it's solve. Yeah, solve. Okay, once you've got it, then that's great, and then let's look at the answer. Okay, right. So what do you notice there? First thing to check is do you have the same base? Well, I've got log base 2x plus log base 2 of x plus 6. Then I've got a 3, okay, plus a log 2 x plus 1. Okay, so what do I notice here?
All the same base.
I've got a log 2, I've got a log 2, I've got a log 2, but there's a plus 3 there. Do you see that? Okay, so if I've got a plus 3 there, how can I write a plus 3 as a log 2?
As an exponent.
No, as a log. Okay, 3 is an answer. Okay, so let's write that down. 3, okay, it's actually here. 3 is the answer. How can I write 3 as a log with base 2? Okay, so am I going to replace the 3?
Yeah.
Of course I will. So let's write down the next line. Write everything else as is, but where you have the 3, we need to convert that to a log. Okay, because then I can work with it.
So how do I do it?
What is 3 written as a log? With base 2. 3 can be written as what? Log 2, 8. Okay, because is log 2, 8 the same as 3? Yes. Right, so now you've got log 2 for everything. Is there a rule that can help us with that? Look at the rules. Do we have a rule? Other page. Which rule can we use here? Which one?
This one.
Log A is 1.
No.
No.
I don't know.
Okay, what do you see there on your page? 2 logs with what in between?
Plus.
Do you have a rule with 2 logs with a plus in between? That's one. There we go. Okay, that's what we're going to use. Why? It looks the same as what we've got there. Okay, so if I have log AX and I have log AY, I can write it as what? Log AX times Y. Okay, so what am I going to do with the left? Write down 1 log, log 2, open a bracket, and then show this times that. So in my question, in this question, x times, open bracket, x plus 6. Close bracket, good, equals, apply the same rule. You've got a plus in between 2 logs.
8.
Brackets, x plus 1, good. Okay, nice. Right, close the bracket, good, simplify. Okay, what's x times x? Yeah, so log base 2x squared plus 6x equals log base 2, 8 times x, 8x, 8 times 1, 8. Good. Okay, does the left equal the right? Yes. Okay, so on the left you've got log 2, on the right you've got log 2. So can I say x squared plus 6x equals 8x plus 8? Yes, therefore. Okay, so therefore, x squared plus 6x equals 8x plus 8. Okay, now you can finish it. Okay, so that was the log part. Log part is just this. Okay, look for the right rule and apply it. Okay, so let's check your algebra. Can you factorize and get x? Okay, I've always given you quite a few trinomials because you've been struggling a little bit with it. So here's a practice one.
Factorize just these 2 or bring it over? Or...
Solve for x. So what would you do? Take everything to one side. Okay, because you cannot solve for x where you have x's on both sides, right? Okay, so I need to take the 8x plus 8 to the left, so I'm left with an expression equal to 0. Okay, then I can factorize. Good.
But you can't factorize 4 things.
Yeah, because I can simplify.
Oh, yeah.
Yeah, the cross method, and try to get your brackets.
The cross method?
Yeah, well, cross, remember, cross to
Isn't
get...
it just plus 2 minus 4?
Plus 2 minus 4, yes. Yeah, and you get that using that cross method. Okay, trinomials, remember? We did lots of that.
Yeah, I know that, but I didn't use the cross method. I just put it in the middle.
It's fine, whichever, as long as you get x minus 4, x plus 2. Good, so x can equal minus 2 or positive 4. Good. Okay, but you have to check. So just asterisks here. With log functions, you have to check them. Why? Because remember earlier, when you do those graphs, do you agree the log functions don't go on one side of the graph? Okay, and the same with the exponential function. I won't get to 0. Okay, remember it's that slanting graph that gets small, 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 but doesn't touch the x-axis. Okay, well, the other graph we drew was the slanting, small, 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 but not touching the y-axis. Okay, so in this case, if you're looking at the question gave you log 2x plus all the others, right? So if I look at the log 2x tells me what? That x is the answer, do you agree? Okay, so if I have log 2 is the base. So the base is what? 2. So 2 to the power question mark equals x, which is the answer. Okay, so is the exponent going to be positive or negative? The exponent has to be positive or negative. Which one?
Positive.
Positive. So what can't I have? I cannot have a negative. Okay, so can I have negative 2? No, I can only have positive 4. Right, so that's the final answer. Okay, so final answer, x equals minus 4 only. And the reason for that is because of those logs and the exponential functions.
X equals 4 minus 4.
X equals 4, as is. Okay, remember you had two answers. Can I have the first answer? No, because that answer is x equals minus 2. Can I have the second answer? Yes, because it's plus 4. Okay. Right, let's just finish off this and then we can start with the other section later in the week. Okay, so there's just 2 more things. I'm not going to do all these graphs, that's a bit too much. Let's just finish these last 2 examples. Okay, so example 4, I think it is. Okay, we haven't labeled the numbers, it's fine. Okay, next example is 2 more. Okay, this one, changing the base of a logarithm. Okay, that's it. This is actually a conversion. Okay, you can say a conversion, converting the base.
And then is there any way our second lesson today we can move to Friday and do a double lesson on Friday instead of
Yeah, that's fine.
Is that okay? So I'm not feeling well today.
Yeah, I've also got a bit of the sniffles today, so I don't mind if we do that. Yeah.
So we can do our double lesson Friday instead.
Yeah, it's just the accounting.
Yeah. Yeah. Okay. Cool.
Okay.
Okay. Thanks.
Okay, so converting.
So I just said changing base.
Yeah, well, changing is the same as converting. Converting the base, changing the base, it's fine. Okay, so the example Let's write it down. Log 429.
Log base 4.
Yeah, log base 429. Okay, so when I have a log that looks like this, do you agree I have a base of 4 and I want to convert it to something else? Okay, so the general equation is this. This you should write down on that other page. Here's another rule. Okay, it's separate to the solving, but it's... Okay, so that needs to be written out. Okay, log A to the answer B, okay, equals, then write that down, log base C B over log C A. There we go. Okay. Underline it, or, well, numerator, denominator. Okay, so what are we going to do? We're going to apply that. Okay, so this is what we had to study. Well, now we've got it. Okay, they didn't give it to us before. It's the first time we're seeing it. But what do we use this for? Changing the base. Okay, converting the base. Right, so if you look at that, do you agree I've got log AB? Log AB is what I'm starting with. If I want to change the base, I can change the base to whatever I want it to be, a C. Okay, then I must just make the B on the top and the A at the bottom. Okay, so what do I have here? Log 429. Okay, so if I want to change the base, the best thing to do is to change this to base 10. Why? Because I can substitute log 10 on the calculator. Okay, so you can change this. So you can say here log 429 equals. Okay, you're going to need a numerator and a denominator. The numerator will be log 10 29 over log 10 4, close brackets. Not close brackets, underline it. Well, show the fraction. Okay, do you write down log 10s? No, you don't. So you can just say equal log 29 over log 4. Okay, and that can be substituted in terms of the answer. So you can solve for each of them in the answer. We'll just write on the answer. Answer equals 2.43. 2.43. Okay. Right, then let's see. This is for log AB. Okay, this is a particular case. So this is special. This gives a source of exam questions. Interesting. Okay, so this could be important for the exam. This needs to be written to that other page. Yeah, so another one to add there. Okay, there's it. Log AB, log small a, big B. Another one to add.
Log small a, big B.
Yeah, equals log B over log B, and then obviously the B and the A. Yeah, so log BB, small b, big B, log BB. Over log small b, big A. Log base B, answer A. There we go. Okay, underline that. So that's the numerator denominator. Equals. Okay, what is log BB? We spoke about it earlier. Yes. Okay, remember we had that log AA? Log AA is 1. Okay, good. So that equals 1 over log small b, big A. Okay, so just draw an arrow here. So what you can do is this. This can be converted to that. You don't have to show this middle bit. Okay, that is the same as that. That's the rule. Okay, so just highlight those two bits. highlight the start and the end. Okay, so if I have something like this, log AB, I can write it down as 1 over log BA. It's exactly the same. Okay, perfect. Okay, so then we've covered all the rules. What was the last bit? This was... this is solving for x. Okay, let's just end with one more solving for x. It's a short one. Okay, solve 5 to the power x equals 13. How are we going to do this? Any idea? Where's those rules? We need them again. Okay, so I've got a rule here. I've got solve 5x equals 13. Do I want x? Yes, I do. Okay, so this you could do on the calculator if you wanted to. Okay, you don't have to do it this way. I don't know what that's a long way to get to the answer. Okay, how else could you rewrite this as? Look at the rule. Well, you don't have the basic rule. Maybe you should add to that basic rule this one, the one that you wrote on the first page. 2 to the power 3 equals 8. 3 equals log base 2 8. Okay, because that's what you study. That's like the everything. And then these are just the additional rules that you would apply. Okay, so would I use that? I would. Okay, so how would I rewrite the x? X would equal what? The exponent equals log. What would the base be? Good. The answer would be 13. Okay, and then you can type that into your calculator. Okay, so I don't know why they wanted to do it. Look at that.
Yeah.
See, okay, that's crazy. It might be because they wanted to simplify, but it's not necessary. They're just trying to show the rule, which, I mean, I'll use the rule if I need to use the rule. Okay, I don't really have to use the rule. Okay, did you get 1,59?
Yeah.
Exactly the same as what they got. Okay. Alright. Is that okay?
Yeah.